In this video, we're going to talk about the differences between linear relationships and non-linear relationships. As you can probably tell from the definition, linear does mean a line, and it is a straight line. So no curves, no bends, no nothings. So on graphs, it is very easy to figure that out. So I'm going to do the graph first because it's really easy. So this is an example of a linear line. It's a nice straight line. This is an example of a linear line. Nice straight line. So we can have proportional and non-proportional. So I can have a positive non-proportional and I can have a negative proportional, as long as they are straight lines. So graphs, very easy to tell if they're linear or not. You just look for the straight lines. Now tables, on the other hand, we have to do a little bit of work, and I'm going to tell you what that work is. It's not very hard. This has to, in a table, for it to be linear, your table must have, and I'm going to roll this down right here so you can see it, a constant rate of change. So basically, what this means is it must have the same delta y over delta x for the whole entire table. Now this does mean in its reduced form. So you will have some cases where the two fractions may not look alike, but when you simplify it down, it does. So here's what we're going to do for table number 1, just to kind of show you. We're going to do our delta y, delta x for our entire table, like we've been practicing for a while. So here, remember, delta y means the change in y. So from 4 to 8, it is plus 4. And we're going to do our delta x over here. So remember, delta x means the change in x. So this is plus 1. The next delta y between 8 and 16 is plus 8. This delta x right here is plus 2. This delta y is plus 12. Oops, too many pluses there. And this delta x over here is plus 3. And this last delta y is plus 4. And this is plus 1 over here. So when we simplify this down, if you see, I'm going to kind of just draw these at the bottom of this table right here just so you can see. Our first delta y over delta x is 4 over 1. Our second is 8 over 2. Third is 12 over 3, and last is 4 over 1. Now do note, not all of these rate of changes are the same, but they all reduce down to 4 over 1. So this is an example of a linear relationship because all of the delta y over delta x's reduce down to the exact same thing. So that's what it means to have a constant rate of change. So we're going to do the same thing over here with this table just to show you one more example. This delta y is plus 4. This delta x is plus 2. This delta y is plus 2. This delta x is plus 1. Oops, plus 8. Let me erase that so we have a clearer. Plus 4. This one is plus 4 and plus 2. So when I set this up again, just to show you, we have 4 over 2, 2 over 1, 8 over 4, and 4 over 2. Again, none of them are the same, but when I simplify it down, they all simplify down to 2 over 1. So because they all simplify down to 2 over 1, that's what makes these two examples linear relationships. They both have a constant rate of change. Now to talk through some non-examples. Again, I'm going to start with this graph right here. Non-examples, so for your graph, for your example, it must be a straight line. So non-examples would be lines that have bends or curves. So this example, it has a bend right here. That is not linear. When it curves like this, that is not linear. When it is a vertical line, it is not linear. And we're going to talk more about that later on. But vertical lines are pretty important as far as knowing that it is not linear for a specific reason. So I'm just going to give you that example. Also, when it curves like this, so pretty much any type of curve results in a non-linear line. It's not a line, it's a curve. Now, as far as your tables go, this is where it's pretty much the opposite of what we did with the linear. For non-examples, for non-linear, it does not have the same delta y over delta x. So when we do our delta y over delta x's, they will not reduce down to the same thing. So for example, this delta y is plus 3, this delta x is plus 1, this delta y is plus 5, this delta x is plus 1. I can already stop. And the reason why is because these delta x's are the same, but these delta y's are not. So when I have 3 over 1 and 5 over 1, we can already tell that this will not be linear because they are not the same fraction. Same thing over here, so I have a plus 2 for my delta y, and for my delta x, my change in x, I have a plus 1. This change in y over here is plus 5. This change in x over here is plus 3. So as of right now, I can't really do anything about this because so far it could be right. But what I want to show you is when we deal with this, you continue through the whole table to see if you have any repeats of anything. So right here I have a plus 2. Oh, but here I have a plus 2. So if you notice at this top part right here, I had a delta y that was plus 2, and here I have a delta y that is plus 2. So for this to have been linear, these two delta x's should have been the same. You can also test that with this next one. This was plus 4. This is plus 3. You have the same ones right here, plus 3, plus 3. So this plus 5 and this plus 4 should be the same if it was linear. So that's how you figure out linear versus not linear. You must check your delta y over delta x to see, is it the same? Then it's linear. If it's not the same, it's not linear.